If you haven't done so yet, please pause the video and try to solve the question before listening on. What we want to do first is figure out the total length of wire being used in the question. Now, the question notes that there were 2 copper wires and they are each 50 meters long. So indeed, the total length would simply be 2 multiplied by the individual lengths. So we can see that that length is going to turn out to be 100 meters. We were told that the resistance of each wire is 0.108 ohms per 300 meters. So we can actually set up a proportion to figure out the total resistance. On the left side of the proportion, we will give the resistance per 300 meters that was stated in the question, and then we can call this resistance X since we don't know it, and then our length is 100 meters. To solve this proportion, we could cross multiply. So if we did that, we would get 300x is equal to 10.8, and then we could divide both sides by 300, and we would get a resistance of 0.036 ohms. We next note that the potential difference at the house will equal the potential difference produced by the utility company minus whatever potential is lost in the electrical lines themselves. The question noted that the potential difference supplied by the utility company was 120 volts, so we know the first delta V on the right side of this equation. For the potential difference in the lines, we would just remember that potential difference is equal to a current multiplied by a resistance. Now we just figured out the resistance of the copper wires, and the question states the current. So we can plug that current in as well as the resistance, and that's going to give us the potential difference encountered by the lines. And when we process that calculation, we get a value of 116 volts. So this would be the correct answer to part A. And then for part B, to calculate the power delivered to the house, all we have to do is take the current and multiply it by the potential difference at the house, which we just figured out. And that turns out to be 1.28 times 10 to the 4th. And the unit of power will be watts. If you wanted to convert that into kilowatts, you can just remember that 1 kilowatt is 1,000 watts. And then once you cancel the watts and divide by 1,000, you would get 12.8 kilowatts. So that's an equivalently correct answer to part B. Thanks for watching. If you liked the video, please click the thumbs up icon and also subscribe to the channel. Remember, you're welcome to send in your own question to this email address, and I'll do my best to post an answer to it on YouTube.